calculate the work done by the gas in the expansion against the external pressure. Work done. We have to calculate the work done by a gas in the expansion against the external pressure. See, a gas is in this cylinder, piston is there, and we have applied P pressure. The area of cross section of the cylinder, that is A. The force exerted by the piston, the force exerted by the piston on the gas, that is force equal to pressure into area. If the gas is expanded by reducing the weight, this weight, then displacement of the piston is delta x. Hence the work done by gas on the small displacement delta x, then delta w is equal to force into displacement. Delta w work done, force into displacement, then F into delta x. Delta w equal to force is pressure into area. Force is pressure into area into delta x. And A into delta x, that is P into delta V, volume. Area into displacement, then this volume, delta V. If at pressure P, the volume of gas change from V1 to V2, then the work is done by, then W is equal to summation of V1 to V2 P into delta A. Summation of V1 to V2 P into delta A. This can also be written as W is equal to integration of V1 to V2 P into delta V. This will be delta V, not delta A. P into delta V. And this is the work done. This is expansion of work done. This. In isothermal process, the temperature of the system remains constant. In isothermal process, the temperature of the system remains constant. Hence, the internal energy of system will not change. Temperature is constant. It means internal energy of the system will not change in case of isothermal process. Then first law of thermodynamics, delta Q equal to delta W plus delta U. Delta U is 0. Then delta Q is equal to delta W. In case of isothermal process. Hence, the amount of heat given to system in isothermal process is equal to the total work done in case of isothermal process. Now, adiabatic process. In this process, adiabatic process, the amount of heat of the system does not change. Amount of heat, it means delta Q equal to 0. By the first law of thermodynamics, delta Q equal to delta W plus delta U. Now delta Q equal to 0 is equal to delta W plus delta U. Now delta W equal to minus of delta U. Here the work done by the system is equal to the decrease in internal energy. In case of cyclic process, delta U equal to 0. In cyclic process, there will be no change in internal energy, delta U equal to 0. Then by first law of thermodynamics, delta Q equal to delta W. The heat is given to the system in cyclic process is equal to the work done by the system.